the recording. And as always, this session will be recorded and made available on our website, pragmaticworks.com, under webinars and past webinars by the end of the week. So if you missed any part of it, please check back. And Laura, if you're ready, I'm going to change screens and make you presenter.
That'd be great. Thank you.
Thank you. Everyone, enjoy your session.
Okay, let me hide some of this stuff.
I like the elephant.
Bear with me 1 second. Not as familiar with these tools. Oh. Okay. Can you still hear me, Rachel?
Yep, I can hear you very well.
And can you see my screen?
I can. I like your elephant picture.
He's just peeking in over there. Well, hello everybody and welcome, and thank you for joining me today to talk about big data and what Microsoft is doing around Hadoop. Really exciting times. I've been involved with these projects since late last summer, early fall, and it's just been incredibly exciting to really learn about what we're doing and the direction we're taking, and I hope that you share my excitement after we talk through this content today. I just wanted to give you a little bit of a level set that the things that I'll show you today and the things that I'll talk about today, in some cases will be available in a current CTP that's available by invitation, and I'll talk through and walk through how to get those invitation codes. And in some cases they're going to be coming later this year, so I'll try and make sure that I draw the line about what we have available in CTP today, what's coming a little bit later. And I know a lot of people are initially going to say, well, when are they going to be available, and can you give me dates? I can't give dates today, but I will ask you to just kind of keep a watch out there, because we'll be making some announcements over the next couple of weeks about some new things that are coming. and if you follow me on Twitter, I'm SQL Gal, and I'll make sure that I'll be tweeting this stuff as well. So if you're really interested in knowing more about what's coming in the next couple of weeks to be announced, do keep an eye on my Twitter handle SQL Gal. Microsoft BI and the SQL Server handles will also be making some of those announcements. So as we start trying to get our arms around what big data is, and I want to just kind of, again, make sure everybody understands what the context of why we're doing what we're doing and the direction that we're going. And there's a ton of data. And we're seeing things like lots of social media data, lots of experimental data, lots of scientific data, lots of manufacturing data. It's actually coming from every sector of industry. Every vertical, every industry is being impacted by this new thing that's called big data. And in some cases it's a new thing, in some cases it's really just a bigger thing of what we've had already. But it is truly just around that data explosion, and data explosion is dressed in multiple facets. So we'll be talking through what those facets are, but in some cases it's truly just from large volume, but there's also other facets that indicate when something starts to tip over to be something that's quote unquote big data. One of the visible representations of big data has, in the past year, really jumped to the forefront, and that's Hadoop. I'm going to dive a little bit deeper into what Hadoop is, what the structures are, and how this thing is set up, to give everybody kind of a level set of what Hadoop is. And we'll also be walking through some different scenarios on how you can leverage Hadoop using the Microsoft solutions, and really help to bring this data together, both your structured and your unstructured data. By and large, when we're talking about big data, we're talking about data it could be structured, but in many cases, in many cases, it is unstructured or semi-structured. In many cases, it's unstructured. We're talking about things like web logs. We're talking about things like the signal data that's coming from machines or from plants or from your energy sensors or other sensors. These are those new types of data that are really creating this deluge of data that nobody actually wants to let go of. That's one of the interesting facets of this, that people are kind of holding on to this data and making decisions that, it's really costing them very little to hold on to it, and they may want to reason over it in the near future. Some interesting statistics, just to kind of, throw some numbers around what this means. Twitter, for example, they generate, as of the last report I saw, which I think was last June or July, they were generating 12 terabytes of data a day. So all of you that are out there tweeting right now, you're just adding to this multiple terabytes per day. And as you may have heard, this is all going to the Library of Congress. So at some point, Library of Congress is going to have to figure out what they're going to do, and they're probably reasoning over that idea right now. From the Bing perspective, we've got Bing, and they ingest 7 petabytes per month. So they're bringing in tons of data and leveraging their infrastructures to help bring the information back to our users. From a scientific community, the Large Hadron Collider at CERN, that actually generates 40 terabytes per second. So that's a lot of information that's being collected, and at some point you really have to think about, how am I going to store and manage this data so that I can actually leverage it in a scalable format. So as I mentioned, there's multiple facets to what big data is and what it means, and by and large people talk about either the 3 V's or the 4 V's. The 4 V is the one that, it depends on who you talk to. If they're the purists that say, no, it's only the 3 V's. But volume is the first one, and that's the easiest to understand. That we've got big data because we've got a lot of data. We've got petabytes of data, we've got hundreds of terabytes of data, we've got a lot of information, a lot of data that's being stored. One of the other facets is the velocity of the data, and this is where things like, as we start talking about Stream Insight as an example, is one of those technologies that helps address some of the velocity facets of big data. That's where data's coming in so fast, and you need to be able to process that data real time or very, very near real time with very low latency. That actually is a big data. It's a big data opportunity, we'll say. Not a problem, it's an opportunity as well. Variety absolutely comes into play, where we've got many different formats. We've got data that's being stored in structured formats within our SQL Server worlds or other database management systems. We may have that data that's sitting in unstructured formats as well, and it might be coming in through XML, it might be coming in through text files or other log files or systems like that. But all of this has to be consumed in a way that can add information back or give information back to our users. The 4th V is the one that I think is the most interesting, but is the one that's, like I said, it's the new kid on the block. That's variability. Some people go, well, isn't that the same as variety? And variability is best characterized by an example. And the example that I had read about was the Watson, IBM Watson, who competed on Jeopardy. It's the computer that competed against the champions on Jeopardy. Variability is characterized through Watson because Watson not only had to very quickly bring in those questions and interpret the questions and find the answer, but the words within the questions may have different interpretations given the words that precede it or the words that follow it. The English language itself is very complex, and the meaning of a specific word could change based on the other words that are surrounding it. So that's the best characterization of variability. A really great write-up of the 4 V's, if you're looking to try and get a little bit more than a 3-minute summary of this, I would recommend going down to that NoSQL's mypopescu.com post down below and look at the definition of big data. So what are some of those patterns that are emerging that we're starting to see? And we alluded to some of this earlier, that people are holding on to information. they're recognizing the fact that it's actually not that expensive to store the information, that they can hold on to data that they're collecting from multiple systems and just throw it into something we're calling this digital shoebox. It's basically where, you know, I don't know what I want to do with this, and I don't know if there's any value in this, but it doesn't cost me much to hold on to it, so I'm going to actually just kind of store this off in some very cheap solution, commodity solution off to the side, and I might do some analysis over it later. Now, recognizing that the analysis over something like that, given the nature of the data, you know, it's not necessarily going to be the split-second response time, but there's possibly, as I talk to people, I'm like, it's kind of like there may be gold in those hills. So we want to hold on to the information to find out if there's any nuggets of real gold that we can use to move our company or move our decisions in the right direction. So that's where, you know, with the information production, you may mine through that digital shoebox and try and look for insight and reason over all the data and help feed those downstream systems. You might actually use that digital shoebox to produce information out for other consumable feeds or enrich your existing infrastructure. Another thing, and this is probably where there's a lot of value as well, it's that you can provide some real analysis over the ambient data, over that digital shoebox data that can help you monitor and improve your systems, improve your ecosystem over time, your whatever data you're storing. A very canonical example is weblogs, for example, that people may store all these weblogs off in this digital shoebox, and being able to mine through that information and understand where there's perhaps some fraud or some, you know, commonalities or patterns that you're seeing on how people are clicking through your websites, or understanding how they might be leveraging your ecosystem. That's where you can try and optimize towards those behaviors. And in comes Hadoop. So this is where we start to think, well, what do we do with this digital shoebox, and how do we store it? What are some of the patterns that we're starting to see with our customers? And we've talked with so many customers over the last couple of years about what they're trying to do with this deluge of data. And there's obviously, you know, the two approaches. And I'm going to take this great example from Denny Lee. He's a great friend of mine, and I think this really helps kind of explain the choices when you're talking about scale up versus scale out. Denny presented it by saying, listen, you've got something like the Hubble telescope. This can go and go straight out into space and find these fabulous pictures and bring information and take these beautiful pictures that are millions and millions of light years away. And it's this big, expensive, non-commodity, specialized equipment, but what it does it so well, and it does it within this very structured format. This is synonymous to that scale up, or the way that you might look at the server approach, where you want to really have a very finely tuned analysis, and you know the information that you're looking for, and you know the information that you're storing, and you can leverage the hardware and the system to really take advantage of that. On the other hand, there's the scale out, or commoditized distribution, and this is another example where Denny suggested, well, if we look at SETI, and anybody who's out there and into space and technology probably knows about SETI, which is Search for Extraterrestrial Intelligence. And this is where, you know, it's great to have that Hubble telescope. It can go grab these beautiful pictures, but what if there's a lot of signal data that we're collecting back? And what SETI does is they're actually going out and looking for extraterrestrial intelligence by listening for radio waves, because they believe that that's probably the best indicator that there's actually, you know, life out in space, that we'll start to see some radio waves. So the way they do this, they have multiple observatories that are all over the world. They're collecting this information. They bring it into these great big data centers and store the information off in the data centers. But then there's the processing of the data. And what they have, they've got 5.2 million participants who have basically said that SETI, yes, you can run a screensaver. So when my computer is sitting idle, a screensaver will pop up, and chunks of data will be passed down to the screensaver, where it will leverage your computer to do the processing of that data, to look for the patterns. So this is a true scale-out approach in its purest form. This is analogous with what we're talking about when we're talking about solutions like Hadoop, where it's distributed and calculated locally. So you're distributing the data out, you're calculating the data where the data is located, you're engaging with tens to hundreds to thousands of machines. There are lots of points of failure. At any time, one of these screensavers could go down. But that's okay because they've got auto-replication that prevents it from being a problem and actually is replicating to multiple other computers that are processing at the same time. So if yours doesn't end up bringing back the results, it's okay because somebody else will take care of it. So enter Hadoop. This is, again, the most visible face of big data. A lot of people, you know, whether it's right or wrong, they typically think, well, what is big data? Big data is Hadoop. Hadoop is basically a technology. It's a set of technologies that is developed in the open source community. It's an Apache community project, and it enables analysis for semi-structured and unstructured data. It's going to distribute it across commodity servers that are all within a cluster. There are two major components within Hadoop. The first is at the bottom right-hand corner that I'm going to talk about, and this is the HDFS, or the Hadoop Distributed File System layer. The Hadoop Distributed File System layer is basically the infrastructure that Hadoop implements to store the data across multiple nodes. It has a single name node that understands where all the data is located. So it will know that this chunk of data that has certain information, this is being stored off on data nodes 1 and 2 and 3. And this other chunk might be stored on 2 and 3 and 4. And what you are starting to hear is that it also bakes in a replication scenario. So there is already data that's replicated across multiple nodes to make it resilient against server failures or node failures or job failures. So the HDFS layer is that bottom layer that really is all about the data storage and the solutions that help maintain and keep that system up and running. The upper picture that you see represented is a depiction of the MapReduce layer. And a MapReduce layer is basically going to consist of a job tracker and a task tracker. Basically, every query that you're going to send off, it's a job. So a job is going to get sent off, and that's going to create a bunch of tasks. These tasks then will process your data and shuffle the results and put them in a nice sorted order, reduce them, aggregate them, and then bring the output back to your screen or whatever application has asked for it, to the client application. So this works in tandem with HDFS in that it's going to push out these tasks down to the data nodes and run them locally. So the real beauty of the Hadoop is that it's really focusing on moving the processing closer to the data and then bringing those results back. One of the things, and we'll talk about some of the differences between a relational system and a MapReduce system that we're talking about. And we'll get to that in a little while. But the big call out when we're talking about Hadoop is, you know, everybody's like, well, what's the big deal about Hadoop? Why is everybody so focused on Hadoop? You do see that other vendors have their own HDFS or their own MapReduce solution, and there are others that crop up every now and then. The thing that captures the attention and the hearts and the minds of so many people who are looking for these solutions isn't just the MapReduce and the HDFS layer, so that green part down below, that's Hadoop. the thing that captures people is everything around Hadoop. There's an entire ecosystem of tools and solutions that help you mine the data, as in Apache Mahout, or Mahout, depending on how you want to pronounce that. Whether you want to be able to query the data or script across the data like you might have with Pig or Hive, leverage a development environment like KarmaSphere, or integrate and share data between systems like you have with Scoop. This is the ecosystem that's really capturing the attention of everybody who's been kind of going, oh, what's Hadoop? And so what I'm going to do is we're going to walk through some of the solutions that we have with the Microsoft solutions that we're going to be delivering. Some of this is available today. So we already have Scoop connectors, and this is, as we'll talk about later, the bi-directional connectors, so that if you wanted to write data from SQL Server down to Hadoop, or if you wanted to write data from Hadoop up to SQL Server and share the data between relational and non-relational systems, the Scoop connector is available for download today. So we're going to talk through the Pig and Hive in a little while, and but before we get there, I want to actually walk through what will Microsoft be doing and what are we delivering. There will be and actually is a Hadoop deployment on Microsoft, a Microsoft Hadoop deployment solution. What this means is up in Azure or on-premise, you could set up Hadoop on Windows. What I didn't mention before when we were talking about Hadoop, it's an open source technology, and today Hadoop is tied to Linux. There is not a Microsoft solution. But as you'll be seeing here, we are committed to creating a solution that will run on Windows and run up in the cloud. You may hear about things like an EMR solution. It's an elastic MapReduce solution. This is the ultimate in elasticity. It's basically, I want to just fire up a cluster of Hadoop really fast, get it up there, run my calculations, pull my data up there, run my calculations, pull back the results, and then I don't care anymore. It's going to go away. This is that bursty batchy workload that you typically have heard about when we're talking about cloud solutions. It's a very simple management and deployment process. So it's not like you have to go up and manage your cluster. It's all self-managed up in the cloud, but you will be managing the actual processing and the real heart of the solution. So it's more about how do you want to analyze the data than it is about how you're going to set up Hadoop in the cloud. Another thing I didn't mention when we were talking about Hadoop is it's not, if you're pulling the solutions down from Apache, the Apache Foundation, it's not necessarily the easiest thing to install and run Hadoop. It does take quite a bit of work around getting this set up within your infrastructure. So having something like that with the EMR solution really simplifies things. One of the other solutions we'll provide is if you want to have your own dedicated cloud cluster. So this is, you want to run it in Azure, but it's not bursty or batchy. You want to keep it up there. It's going to be dedicated. You're going to keep your data up there. It's not going to walk away in a couple of days. This is our second deployment model that I'm talking through right now. This provides some elasticity, and it depends on how you set up the storage and partitioning, but this is basically saying I want to run Hadoop up in the cloud. The third is the dedicated on-premise cluster. So you want to run Hadoop on Windows Server, and you want to do it within your server room, within your four walls. So you're not interested in the cloud for this data. It's just not something that you've considered, or it's just not ideal for the patterns you're looking for. So you want to store it within your server. And this is where we're going to be really providing some of the great things like we've committed to, and we're looking at things like integration with Active Directory, integration with System Center, some really great things to make this enterprise manageable within your enterprise. So with that, we've spent a lot of time talking, and why don't we just, I'm going to jump into some demos, but I've got a couple of screenshots because, you know, my demo environment I've already kind of walked through and done the setup, but I did want to at least show you what that setup might look like as you get into your environment. So the first thing you would do is you would go to www.hadooponazure.com. And when you get there, you're presented with this beautiful picture and a suggestion to sign in. And what you'll see hidden somewhat towards that sign-in is that it's available by invitation. So if you don't have an invitation today, then what you'll want to do is click on that little invitation and say, you know, and fill out the survey. The invitations they try and get out at least once a week, and we queue up the invitations. It may take a few weeks before you get your code, so I want to kind of do some level set that just because you fill out the survey, you're not going to get the code right away. We are dealing with a lot of people interested in this, and so we're handing out the invitation codes through batches. But once you do get the invitation code and you sign in, the first thing it's going to do, and this is the EMR or Elastic MapReduce, the bursty batchy kind of CTP. So it's going to ask you to give your server a name, and in this case I gave it SQL. There we go. I gave it SQL Gal. And it's going to ask you what size of cluster. Do you want a small, which is 4 nodes with 2 terabytes of disk space, all the way through medium, large, and extra large with 32 nodes and 16 terabytes of disk space. Once you give your cluster login name, you're done. In a couple of minutes, or more than that, depending on the size of cluster you chose, you'll have your cluster presented back to you. And so why don't I actually jump over and show you what that looks like. And let's jump in. So once you're in and you have your cluster set up, it's going to look similar to this. Now you won't have any of these purple boxes. You'll have just the one box that says Create Job. I've already created some jobs and had some things running. This is information about what's happening on your cluster, the jobs that are running. You'll have a section about your cluster, so how you can manage it and connect to it. And then you can manage your account, and we're going to start down here, and I want to point out a couple of interesting areas. First off, in the samples area, there are a lot of great samples to walk through, just some very, you know, hello world kind of examples. Different scenarios, whether it's doing clustering algorithms or the scoop and integrating with SQL Azure or SQL on-prem. Doing a canonical word count, which we'll walk through that example in a bit, etc. One of the other areas I want to point out, and this is going to be relevant as you start looking at how you want to leverage the BI stack, is the downloads. So if you wanted to leverage your Excel to be able to connect directly to Hadoop, and I'll walk through that scenario in a little while. You'll need to download these drivers or one of the drivers and install that based on your Office setup, whether it's 64-bit or 32-bit. So those are available in downloads. I just wanted to point those out. And then job history is where you can look at all the things that you may have run on your cluster since you started the cluster, and it gives you oversight as to where things might have completed, and you can see the code was okay. You can drill in and see what happened and what was the output and all the interesting information about the job. But it also can point out later something went really red and failed, and you can go dive in and find out why that failure occurred. So as we move up, so you know we started down in the manage, and we're going to just move up a little bit, and what I want to do is point out a couple of areas. So when you're starting to leverage your cluster, a couple of the things that you'll want to do first, depending on how you want to get data in there, you'll need to walk into this open ports tile. And this is where you simply are going to say, well, I want to open or I want to close the ports. And this allows you to do things like do a remote desktop or connect your ODBC driver from your Excel up to the cloud solution. If you're trying to run through some examples and things aren't working, make sure that you've opened the correct port for that particular example. So once you've got your ports open and you've identified what samples, maybe you need to think about how am I going to get data into my cluster. So I've got maybe some text files or I've got some other data that's sitting on other systems, and I want to bring that into my Hadoop on Azure cluster. How do I get my data into the system? And then once we have the data in, we'll talk about some ways to get the data out of the system, and that's through our jobs and our querying. So I am going to point out a couple of areas. So the first one we'll walk through is if you go into Manage Cluster. And within Manage Cluster, you can see that there's a couple of options that are available for you. One of the first things that I'm going to point out is you can set up a Windows Azure storage environment. So if you have data that's being stored up in the Windows Azure Blob Storage account, you can very easily connect it by giving the storage account name and the passkey. And if you don't have these today, you can go set up an account with the Windows Azure tools and utilities and give that a try. I think there are free trials available. One of the other ways you might want to bring data into this environment might be through something like Windows Azure Data Market. And so this is a great way to leverage things like you've got data that's being stored up in the data market. You want to pull that into your Hadoop environment. And if we go out to datamarket.azure.com, you'll notice that there's lots of different dates you can pull from. I like to look at free data feeds when I'm running my examples, so we'll just pivot on data that's free. And from here, there's still a lot of choices, so I'm going to drill in and let's look at demographics just because that looks interesting. Now, I've already subscribed some of these already. You can see that through, this data subscribed. And if I haven't subscribed, I could click on it and then easily subscribe after I've set up my account, of course. I want to perhaps use this gender information. So I'm going to click on my Use tab, and we're going to leverage this particular set of data, and I want to bring the values of this query into my Hadoop infrastructure. So all I'm going to do is just run the query, and I can look through and see, well, yeah, that actually looks interesting. It's the gender statistics across different countries for different facets of demographics, so it does seem pretty interesting. So once I've decided what I want to bring in, there are a couple things I need. So if I click on this Develop tab, this query is very important. So I'm going to copy this query. If we go back to my Hadoop on Windows or Hadoop on Azure, you'll notice that I have to put in a query. So we'll add our query. And I'm just going to remove that top 100 because I want to pull in all the values. I also need to provide my username and then a passkey. The passkey is the passkey that's available with my subscription. So this is somewhat hard to see, but at the very top you'll see this primary account key, and if I click on that, I can paste it or copy it and then paste it over to my passkey. And finally, I just need to give it my table name, and maybe I want to call this something like my pragmatic works, gender, demo, something like that, and I can then click import data. So it's going to start pulling the data from my data marketplace subscription and import that into HDFS. One thing to be aware of, this is not like a traditional, structured system or, ecosystem like that. This takes a little bit of time. This is going to take a couple of minutes. So we're going to actually just let this run behind the scenes, and we're going to go back to our beginning. So we've got data that's being imported. And we can look at the job history and see how things are going a little bit later. But we've talked about a couple of ways to pull data in. Let me show you a couple of other ways. And this is where we start looking at how we can interact with our data. I mentioned to you that we've got some different things within the Hadoop ecosystem that are really interesting. One of which I mentioned was Hive. Another I mentioned was Pig. These are languages that help you interact with Hadoop. Traditional ways to interact with Hadoop, or if you wanted to write your own MapReduce jobs, you essentially need to know Java. If you don't know Java and you're not interested in going down at that level of control over how that job is executed, the MapReduce job, you can leverage things like JavaScript and Hive and Pig to help you more easily interact with Hadoop using, I guess they'd be called meta languages. So in here, if we go out to Hive, I'm going to start with Hive because Hive is really interesting for people who are data professionals because it uses a language that's called HiveQL. So if I come out here and I say, show tables, you'll notice that we're actually going to have tables. So you say, wait a second, you said there was all of this unstructured data. How can we have tables when there's no structure to the data? You actually can create structure over the data. So this is where you do kind of this, you're going to create a meta layer and say that this set of web logs are actually going to be structured this way so that I can interact with it using my common tools such as Excel or Power Pivot and bring the data up through Power View later. Once I see my tables, maybe I want to say, well, describe Hive sample table. And this is where I can have a look at what the columns are that have been declared within that table structure. As notice, it's not the fastest, but it does eventually come back. So I can maybe do some other interesting things. You know, maybe I want to see the select count. Whoa, bad. Never type in a demo, right? And we'll call this a device make from Hive sample table. And what I'm trying to do here is just demonstrate that this is actually very close to SQL, and by and large, it leverages a lot of the same functionality as SQL. There are going to be some differences, but by and large, this is going to be a much easier way for people who are very familiar and comfortable with traditional relational database systems and the SQL language to make that transition over and be able to integrate with their Hadoop infrastructures. So you'll see this is going to take a little bit of time because, like I said, it's not the fastest. This is designed just to level set. Hadoop has been designed to work across hundreds and thousands and tens of thousands of nodes, individual computes that are running and processing this data. It's designed to run against terabytes and petabytes of data. This isn't designed to provide a sub-second response time for a query, but we'll talk about how to leverage all of the tools together to provide a more agile and fast and low latency analysis environment over Hadoop. So this is going to take a little bit of time, and like I said, I don't know that it's prudent that we need to sit and wait for this paint dry, so I think what we'll do is we're just going to move on. One other place that I do want to point out that we can bring data in, so we talked about how to bring data in. We'll go back into the interactive console, and this is where we can do something like JavaScript. JavaScript is a real easy way for you to basically send off MapReduce jobs, write MapReduce jobs, and get that information back. So I might be able to do something like an ls, which is, just show me everything that I've got in my file system, and it's going to provide a view like that. Now, I may want to say, well, let me see what is in that word count, and I want to actually inspect what's being sent across the wire here. So this is the JavaScript job that is going to basically do a word count over a file. Now I've got a file that I have done, that I've put in my system, and I could put files in. So we talked about how do you get data in. I could do a put. Hold on, what am I doing? And when I issue the fs.put, it's going to bring up an upload file. And here I can browse on my current system, and I can browse the internet, and I can say, well, you know, I'd like to bring in these data, this data here, and I want to put it in this destination. It will throw it into a folder structure that's up in Hadoop. That I can put in right here. Now I've already got this listed in here or uploaded to here, so I don't need to have that right now. But perhaps I'd like to run my word count job. So once again, you know, this is something that takes a little bit of time, but and I'm not going to type this out. So what I'm going to do is I'm going to paste this, and if we look at what we're actually going to be running, it's issuing a pig job. Pig is a scripting language that is another abstraction layer that makes it very easy for you to interact with Hadoop. Trying to interact through the pure Java language can be pretty difficult. Pig kind of basically is an abstraction layer, so as Hive is, so that you can write something as in Hive, like a SQL command. Behind the scenes, what it does is it translates it to a MapReduce job and sends it off to Hadoop, and then brings back the results. So you don't need to write MapReduce jobs, you actually write SQL. Pig, likewise, you're going to write a script, and it's going to translate that script to a MapReduce job. And in this particular case, it's going to take my DaVinci text, which is a text file of all the DaVinci works that he's written in his notebooks, and it's going to issue that word count JavaScript, and it's going to bring back the top 10 words that are in that particular command. Now, I've run this already, and in the interest of time, we don't want to wait 3-4 minutes for that thing to issue. So I'm going to actually just do a read, and let's have a look at what those top words were. And we can see, well, of course, "the" seemed to be a pretty popular word for him. Now, I've added that the results of the read command into my variable on the file. And now I'm going to take that variable and I want to parse it. So we're going to do basically a pivot on that word command. So we're going to issue this out, and we are again pivoting that off, and I can put that into another variable. So the final thing I want to do is within my JavaScript environment, I want to just see this in a graph. I can do a pie chart, I can do a graph. We're actually going to issue the graph.bar and put that data variable, that's pivoted data, and we can see the results in a nice bar graph. This is just, again, a very easy way to interact with your data that's sitting in Hadoop by using JavaScript up in Hadoop on Azure. So we've put data in a couple of ways. We've done the JavaScript put. We've done other things. We can absolutely use other systems as well if you want to use curl or you know, your favorite of choice to get data up into that cloud ecosystem. And when things are on-premise, of course, you've got a lot more agility for how you get that data in and where you want to pull that data. So that's just a general walkthrough. Again, up here is just a view of the jobs that have run already on my cluster in the background. This is where we can have a look and see, well, what were the actual results of the word count example. This is a word count of all the words, so it wasn't just the top 10 words. And I can see the history of when that job may have failed and have a look and see why it failed, or have a look and see where things did work. Now, when you are in the Elastic MapReduce, you are not just tied to only using this interface. Let's say you actually want to get on the server and run some things directly from the server. Remote desktop is right next to the interactive console, and this does require that the FTPS port is open, and once you've opened that, you can click on here and say, well, I'd like to do a remote desktop. It's going to basically give me a warning and say, are you sure you want to do this? So we will say, give it my password, and fairly soon it's going to pull open my remote desktop that is, oh, here it is. Again, it's warning me You sure you want to do that? And here I am, and you can see it's just like I'm interacting with any other server. I'm actually on my cloud in my EMR hosted cloud solution. I can look at the command prompts. I can pull data. I can push data. I can store information up here and interact with it from this particular perspective. If you are familiar with Hadoop, and if you have worked with Hadoop in the past, one of the things that you'll be familiar with are these consoles, and you may remember when I showed you the job history and how, you know, the jobs that were sent, and you can see when they failed. It's not quite as easy or evident from the plain vanilla solution that comes directly from the Apache Foundation. So in here, if you come out to the local host, 50070 basically. This is where you can do things like I want to browse the file system, I want to look at the logs, I may actually be interested in looking at the MapReduce history up here, and here I can see what jobs have been running, are there any jobs running right now, and what jobs have completed. So here you can see a couple of completed jobs, and some of these were the jobs that we just sent off. So it's not quite as easy to follow, but that information is available as well. Okay, so let's go back and have a look at some of those slides. No, just not here. So when we're talking about things like MapReduce, or we're talking about Hadoop, which is an implementation of MapReduce, we are comparing that with traditional relational systems. You know, Tom White wrote a book called Hadoop, the Definitive Guide, and this is actually in the very first chapter. It's a fairly nice chart to get your head around why do we have this versus that, and what are the differences. There are some key differences, and you know, the MapReduce, of course, that's got, you know, from terabytes to petabytes, and traditional relational databases, you know, they have the capacity to go to terabytes, but as you look down towards the bottom, the scaling is where things get interesting. So as you add more nodes or add more compute power to that relational system, you're going to have a non-linear improvement, performance improvement. Whereas with MapReduce, it's pretty close to linear, meaning if I start with a 4-node server and a job takes 30 minutes and I add 4 nodes to that cluster, my job's going to take half the amount of time. It's a pretty linear environment or a linear solution. Other things, the access methods of a traditional relational system are interactive and batch. So you're going to do reads and writes back and forth. But with MapReduce, it's a batch process, and it's write once, read many times. So this isn't going to be like, I want to go update, you know, my top 3 values. It's a different solution than that. This is write, you know, read. It's just write and then read many times. One of the very important differences between something like a traditional relational system and MapReduce is how you define the schema. Within a traditional system, you lock in on the schema first, so you know schema first. And before you do anything else, you have that schema defined. Once you have schema defined, you can dump data into that defined schema, and things are going to adhere to the schema. MapReduce, on the other hand, you may not know the schema, you may not care about the schema, you might just need to put the data out there in your digital shoebox, and you'll deal with schema later. So it's schema first for relational, schema later for MapReduce. Later may be defined as when you want to put some Hive data warehouse ecosystem over this, or at runtime. With PIG, for example, you can define the schema at runtime when you issue your PIG command, and yes, they have the best names within the open source community. So they have PIG and they have grunt. The PIG issues a grunt. It's awesome. But when you issue the PIG command, at that point you can say, I want to define my schema this way across the data that I'm going to resend. So what are these other tools we've talked about? First and foremost is Hive, and you saw a small example of this with Hadoop on Azure, and I did point out where you can download the Hadoop or the Hive ODBC driver so that you can install this within Excel. And when you install it within Excel, you'll have a nice little pane that you can interact and query directly against Hadoop, whether it's on-premise or up in the cloud. This is basically what people say it's a data warehouse system for Hadoop. It allows for an easy transition for people who really understand SQL, and that might not just be our SQL professionals, but these could be, you know, our end users that have become quite savvy with writing their own queries. They may need something like this that helps them be able to pull data from Hadoop as well. And what this does is, like I said, behind the scenes it's going to issue a MapReduce job, but it's going to present a nice, easy environment for you to interact with. To learn more, I would go to the Apache Org Foundation. They've got the Hive project, and they've got great documentation, some nice use cases and examples, so I would definitely go there. JavaScript is going to be one of our solutions we're delivering with Hadoop on Azure, and it's an interactive development, and it includes, like you saw, charting and graphing. And I put in a bit.ly link that is a link to the TechNet wiki on Microsoft's TechNet. Our team has developed some really great documentation and videos walking through not just JavaScript, but also a lot of the other things we've shown you today. So I highly encourage you to go learn more about all of these solutions from that TechNet wiki. Scoop is a solution when, like I said, you want to maybe pull data from SQL into Hadoop or pull data from Hadoop into SQL. These are bidirectional data connectors. And it's really key and essential that you understand these are bidirectional. Not every Scoop connector is bidirectional. We are bidirectional. And basically it allows you to more easily transfer data in parallel and provides the fault tolerance that you have with an HDFS to be able to pull data between systems. This is available today, and the bit.ly that I have listed there is available for you to go download. Pig is another data flow language, but this one's more like a scripting language. So those people who are very familiar with SQL will love and embrace Hive first. Those who are very familiar with scripting languages are going to love and embrace Pig first. That doesn't mean that you're only going to live in one or the other. Once you get to know these programming languages, you'll understand how to use them in certain scenarios and how to use them together. Again, documentation, great use cases are available at the Apache organization, and some of the resources I'm listing at the end of the presentation will also show a programming pig book by Alan Gates, and it's a great book, really well written, especially from a technical perspective. It's not boring. He does a really fun job. So we're going to go back into our demo environment, and I want to just walk through a couple scenarios where we want to pull data from our Hadoop environment into things like BI. So in here, I've opened up Excel, and I've basically said, well, okay, in my Excel environment, what I might want to do is just query directly against my data that's sitting in Hadoop. So this is one scenario where I can go to my Data tab, and you'll notice we've got this nice Hive data pane after I've installed my ODBC driver. So I click on there, and I can see that I can connect to my Hive. Now as I look at the drop-down, I've already set up a couple of connectors, or I could set that up live here. I'm going to use my SQL Azure account that I've already got set up, so we're going against our Azure data. And let me put in my password. Hopefully I put it in correctly. I did. And once my password is in, you'll see that I've got some options to look through the data, and you can see, oh, here's that Pragmatic Works gender demo data that we pulled in. So why don't I actually use that as our example, since we did just look at that. We just pulled it in live on the video. And in here I can choose from the columns that I'd like to include, or I could say just do select all. And down below, this Hive QL is the query that will be issued against my Hive environment, against Hadoop. So in here it's actually going to, by default, do a limit of 200. I think that's probably a good thing because we don't want to wait forever for this. So we'll go ahead and just let that execute. As you saw earlier, I could do things like I could say I want to look at group bys. I want to do counts with group bys. I might want to do summaries. I might want to do different aggregations. All of that certainly is available from here as well. Okay, and as you update this up here, your query gets updated live as well. So this is a really easy way for business users and analysts to be able to work directly with data that's sitting in Hadoop. Notice that we did not take that data out of Hadoop. We didn't dump it into any staging area. We basically are going directly against Hadoop. This is really important. Another way that we would want to leverage that data perhaps is in PowerPivot. Obviously, this is a Pragmatic Works webcast, and I know that a lot of people with Pragmatic Works and relationships with them are fairly savvy with BI. But in here, we could do things like I want to go to my PowerPivot window, and in here, I want to pull data from, and in this case, I've got data coming from a couple of different feeds. So if I look at my design window and I look at my existing connections, this is where I could see that, oh, I've got a data feed coming from my Azure Data Marketplace directly. And this is that calendar data that is available from the Marketplace. Really nice solution. And I've also got a couple of feeds that are set up, or a couple of connections set up for my Hadoop on Azure. And if we look and edit in there, you can see my account information is stored right in there. So I've already pulled the data down from this Twitter movie feed, which is just a feed of tweets that people have sent off about different movies within a certain time frame. And from here, just like you could with any data, you've got data that's sitting in Hadoop and data in a relational source. You can leverage PowerPivot to basically bring that data together, mash it together, and provide a holistic single view. So here I've got data that's sitting in my movie data, and I'm joining it off to my calendar data. And of course, at that point, you've then created an ecosystem that allows you to put that data directly into a Power View, so your end users can interact with data in Power View. Now, you may or may not have seen Clout is one of our customers, and they actually have an ecosystem that has a lot of Hadoop in the back end, and as they bring that data forward for analysts to use, they have a very fast second to sub-second response time over billions and trillions of rows of data because they're leveraging analysis services. As the CTO calls it, he calls it his super index of data that's sitting in Hadoop. So he can use Hadoop to continue to do reasoning and research, but when he knows the analysis that he wants to take over that data, he leverages analysis services and our BI ecosystem to bring that data forward to their customers. And we see that same pattern with customers like Yahoo as well. So that is the marketure of the different tools and things that are available. And I know that we're at the top of the hour, and I want to make sure that I'm leaving time for questions. So Rachel, did you have any questions you wanted me to talk through?
Yes, we do have a couple of questions. The first one's from Stephen, and it is, with virtualization of servers with VMware, how is that compatible with Hadoop, which seems to be leverage cheap multiple distributed hardware pieces?
So Hadoop itself is not, it's not virtualization. You can set up Hadoop in a virtualized environment, so you could set up your data nodes to all be virtual machines that are sitting off on physical hardware. I don't have the stats to tell you give you advice whether or not that's a good idea, but that's certainly one way that you can integrate the two technologies, but they are different. So the virtualization itself is something that you could pattern with Hadoop, but Hadoop itself is going to scale across hundreds of nodes in many cases, or thousands of nodes in many cases. you saw my poor little 4-node cluster up in Azure. That's actually very small. Most Hadoop ecosystems have tens to hundreds to thousands of actual compute nodes. So.
Okay, great. And our last question is from Yusuf, and it is, can we use Hadoop to store documents data as blob data?
Yes.
Ah, good.
Easy.
So easy. Well, that's all the
Yes,
questions we have. And thank you so much, Laura. That was great. I actually learned quite a bit.
Oh, good, good. And again, my Twitter handle is SQLGAL, SQLGAL. If you have any questions or feedback about the session, feel free to ping me. I'd love to hear from you.
Okay, and everyone, if you missed any part of this, the session was recorded and it will be posted on our website under past webinars by the end of the week. And everyone, I hope you have a great weekend, and thank you again, Laura.
Thank you.